Hi, this is Mrs. Rodriguez, your algebra teacher. This video is about lesson 10-1, and it's all about square root functions, okay? So let's go ahead and get started. So first lesson, this lesson talks about dilations of radical functions. So a square root function contains the square root of a variable. The square root functions are a type of radical function. And the expression under the radical sign is called the radicand. For a square root to be a real number, the radicand cannot be negative, okay? So values that make the radicand negative are not included in the domain, okay? So first here it says to graph g of x is equal to 4 times the square root of x. So what you want to do is make a table of values, okay? So we're going to put in a value for x, and then we're going to solve for g of x, okay? So let's say we put in 0 for x, okay? And the reason we put it in starting at 0, because remember it can't be negative, so we can't put any negative, we can put -1 in for the square root because that you can't take the square root of a negative, right? Those are going to be imaginary numbers, and we're not going to graph those. Okay, so we've got when x is 0, so that would be 4 times the square root of 0, which is 4 times 0, which is 0. So when x is 0, g of x is also 0. So this graph is going to start at the origin. Then I'm going to put in 1 for x, so 4 times the square root of 1. The square root of 1 is 1, and then 1 times 4 is 4. So when x is 1, g of x is 4. 1, 2, 3, 4. And then I'm going to plug in 4. And the reason I'm going to plug in 4 is because 4 is a perfect square, right? If I plug in 2, I'm going to get a decimal. So I'm going to plug in 4. I know the square root of 4 is 2, and 2 times 4 is going to be 8. So I go over 4, 1, 2, 3, 4, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I put a point there. So I can see what my graph is going to look like. Okay? It's like that. Hopefully yours will be drawn a little better. Okay, so then it says, talks about reflections and translations of radical functions. So remember, just like with parabolas, they can move from left to right, they can move up or down, or they can be reflected over the x-axis. Okay, so if you had, it says here, draw the graph of y equals a times square root of x. The graph starts at the origin and passes through 1 over a. So if a is greater than 0, the graph is in quadrant 1. Okay, so a is the value in front of the radical. If a is less than 0, the graph is reflected across the x-axis and is in quadrant 4. Okay, so if it's greater than, if this is greater than 0, the graph is going to go this way. If it's less than 0, graph is going to go this way. Okay. All right, and then it says translate the graph k units up if k is greater than 0. So if something is being added to, outside of the radical symbol, then you're then it's going to move that many units down. Okay, and if h is this value here, sorry, if k is greater than 0, you're going to move up. Okay, then your starting point would move up, and then if k is less than 0, then it would move down. Okay, all right, and then for the h value, if h is greater than 0, then it's going to move that many units to the left, and if h is less than 0, then it's going to move that many units to the right. Okay. All right, so let's take a look at this problem here. Okay, so we've got the graph y equals -2 times the square root of x. So first thing, this is a is less than 0. So it's going to be reflected over the x-axis. Okay? So I'm going to still make a table. I'm going to plug in some values for x and see what I get for y. So I'm going to start with 0, because remember, x has to be greater than or equal to 0. Okay? So here we've got 0. I'm going to plug in 0 for this for x. So -2 times the square root of 0 is 0, right? Square root of 0 is 0. Okay, so at 0 is my origin. When x is 0, y is 0. So then I'm going to plug in 1. So -2 times the square root of 1. Well, the square root of 1 is 1, and 1 times -2 is -2. So when x is 1, y is -2, which makes sense that our graph is going below the x-axis because it's being reflected over the x-axis. Okay, so I'm going to plug in 4. And the reason I'm plugging in 4 is because 4 is a perfect square. I'll get an exact value here. So 4, the square root of 4 is 2, and 2 times -2 is -4. So that's 1, 2, 3, 4, and then down 1, 2, 3, 4. And I'll do one more. I'll plug in 9, because I know the square root of 9 is 3, and 3 times -2 is -6. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, and down 1, 2, 3, 4, 5, 6. I put a point there. So I can see what my graph is going to look like. Hey, there we go. That's a good one. Okay. So it's reflected over the x-axis. Okay. So then it says to state the domain and the range. So the domain, notice that our x values have to be greater than 0. Okay. We don't have anything below 0. So x is greater than or equal to 0. And then for the range, those are our y values. It's got to be less than 0. Okay, so y is less than 0. There's nothing, there are no positive values on this graph here. Okay, sorry, this is y is less than or equal to 0, because y can be equal to 0. We got that on the first point here. Okay, all right, so let's take a look at another one of these. Now it says g of x is equal to the square root of x minus 4. So because it has this minus 4 outside the radicand, you know it's going to be translated down 4 units. Okay? So if we made our table of values, I'm going to plug in 0 for x. Okay? Remember, for the domain, x has to be greater than or equal to 0. Okay? All right, so I'm going to start with 0. So I plug in 0 for x, and the square root of 0 is 0. 0 minus 4 is -4. And then I'm going to plot that point. So I'm going over 0, I'm going down 1, 2, 3, 4. So my graph is being translated down 4 units. So I expect it to start at -4 on the y-axis here. Okay. All right, and then I'm going to plug in 1 for x, because I know the square root of 1 is 1, and 1 minus 4 is -3. So when x is 1, y is -3. Okay, and then I'm going to plug in 4 for x, because I know the square root of 4 is 2, and 2 minus 4 is -2. So when x is 1, 2, 3, 4, it's negative 2. So I put a point there. And I'm going to do one more. When x is 9, because I know 9 is perfect square. Square root of 9 is 3. 3 minus 4 is negative 1. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 1. So I can see my graph is going to look like that. Hey, that's a pretty good one too. And then I can see that my range, or my y values, so y has to be, if I look at on my y-axis, my lowest point is at negative 4. So y has to be greater than or equal to negative 4. Okay, because my lowest point is negative 4. Okay, and let's try one more. So here I see that I've got y equals negative 2 times the square root of x minus 1. So that negative 2, it's going to make it reflected over the x-axis. Okay. And then this negative 1 over here, or minus 1, is going to mean that it's going to be moved. If we go back, h is less than 0 because it was negative 1. It's going to move 1 unit to the right. Okay, so it's going to move 1 unit to the right. Okay, so let's take a look. I'm going to plug in some values for x and see what I get for y. So first thing is we've got this square root of x minus 1. So remember, x minus 1, it has to be greater than or equal to 0. So if I solve this, or if I isolate x has to be greater than or equal to 1. Okay, so I'm not going to start with 0, because if I put 0, I get 0 minus 1, that's a negative, and I cannot take the square root of a negative. So my values, or my table, needs to start at positive 1. Okay, so I plug in 1 for x, and 1 minus 1 is 0. The square root of 0 is 0, and 0 times negative 2 is 0. So when x is 1, y is 0. Okay, so that shows this part right here is translated 1 unit to the right. So from the origin, it went 1 unit to the right. Okay, so now I'm going to plug in 2. And the reason I'm plugging in 2 is because 2 minus 1 is equal to 1. 1 is a perfect square. And 1 times negative 2 is negative 2. So when x is 2, y is negative 2. And I'm expecting my graph to be below the x-axis because this tells me it's reflected over the x-axis. Okay, so then I'm going to plug in 5. And the reason I'm plugging in 5 and not 4 is because 5 minus 1, I have to take away 1, is 4. And the square root of 4 is 2. And 2 times negative 2 is negative 4. So when x is 1, 2, 3, 4, 5, y is 1, 2, 3, 4. And then I'm going to plug in 10 as my last point, because 10 minus 1 is 9. 9 is a perfect square. The square root of 9 is 3, and 3 times negative 2 is negative 6. So when x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, y is negative 6, which is down here. So then I draw my graph. There we go. Okay, so my domain is when x is greater than or equal to 1. And then my range, remember, are my y values. Okay, so y is less than, right? Less than or equal to 0. Okay, is this my highest point is 0 here. So it's got to be all the values of y are less than 0, okay, or equal to 0. Okay. All right, so that's all I have for you for this lesson. If you have any questions about this video, please call, text, email me, or stop by my office hours and I'll be happy to help. You have a great day.